getting the same answer the Heron's formula gives. So if you understand this procedure of what we're doing today, you understand why the Heron's formula works like that. Exactly the same thing. Okay? So about understanding exact values, right? So let's start with number 29. So this is not an accurate picture, it's just random picture I'm sketching here. I'm putting those three sides, 9 and 12 and 15. An area of this triangle. Then we're going to calculate one of those angles approximately, right? Using a calculator. And then use 1/2 times sine, AB times sine theta. That thing, right? So that's not going to be exact. That's why we're doing slightly different. All right? Who cares about exact values? People out there in the field don't care about this exact value, but mathematicians like it. The reason I'm doing it is it makes you think about more precisely, more accurately, and more mathematically than just relying heavily on calculators. All right. So, but it still uses that formula. So which one is going to be theta? Which one gives you the right answer? Is this theta or theta? Which one? Any of them will give you the... Again, if you look at the algebra that we're doing today, it's more puzzling than why is this, everything is going to be the same. But if I put theta here, theta there, it doesn't matter. They're all going to give me the same area. So let me put the theta over here. How about that? All right. Then, well, yeah. Then we're going to calculate cosine theta. Up to here is the same. So how do you calculate cosine theta? 2 times, right, 12, is that adjacent side? 9 and 12 is 9 squared plus 12 squared minus 15 squared, correct? Yeah. If you look at this angle, 2 adjacent side, those are ABs. Well, it doesn't matter if A is 9, so they're symmetric, so it doesn't matter. But good to know. So it turns out this is 0, right? If you calculate the numerator, it turns out it's a 0. So we're putting it to 0. And this is the stage. We're not going to go to a calculator and hit cosine inverse. That's the one thing that we're not going to do, right? You will get an exact answer because it's very special value. But I will think about this one. I want you to go through angle 0 to 180 degree. That's the meaningful angle for the triangle. See where the cosine value is 0. Cosine value is x over r, right? Is that correct? So, what is x value here? 0, right? If you multiply radius r both sides, correct? So, in your angle here is a positive x-axis, and going in here, where is x equals 0 on the circle? Where is it on the circle? Where is x coordinate 0 in between first and second quadrant? There is one point on the circle whose x coordinate is 0. Origin is not the point in the circle. Circle is on the boundary there, right? What's that? 90 degrees, right? If a 90 degree, at the top x coordinate is 0 and y coordinate is r, right? So that's where the x coordinate is 0, and that's where the cosine value is 0. Does that make sense? Now if you hit calculator, then you're going to get 90 degrees from there. But we're not going to do that. This is something that you run through quickly in our mind. All we need is a sine theta, right? Because if I know sine theta, then 1/2 times 9 times 12 times that sine theta is going to be the answer, correct? We know it's 90 degrees and all that, but I'm introducing slightly general idea that still works for all the other triangles. So if you know cosine value, how do you calculate sine value? We went to circle. So here's a circle. Right, we don't know radius yet. But where is the theta? Cosine theta, which is x divided by r, that is set to 0, right? So we realize that x equals 0, correct? So that's the point right there, because theta is in 0 and 180 degree, right? So what is that point? Is 0 comma r. And that's your theta. Does that make sense? That's right. The whole procedure must be there to compute this one. So what is it we want to compute out of all this? Out of all this circle thing? Right, that's the final thing, but in the intermediate step, I know the cosine theta is 0. I went to the circle like this to compute what? Sine theta, right. So from here, what is sine theta? Y coordinate of this angle, what is it? R, radius, R, right? Radius never changes, so it is 1. Okay? You can verify the sine 90 degree. If you hit calculator, it'll say 1. Okay? So we got sine theta. Here we didn't calculate actually. If you look at it here, we talked about theta being 90 degree, and here is kind of clear, but I didn't really calculate theta. All I calculated is what is the terminal point. From there, I calculated the sine theta value. Remember, I give you cosine theta, 11 divided by 12, and you calculate the sine theta going to circle and all that. I did exactly the same thing. So what is the area of this triangle? A is 1/2 times 2 adjacent sides, 9 times 12, right? And sine theta, the sine value of the angle in between. Isn't that right? So just knowing that cosine from law of cosine theta value is 0, we could conclude that sine theta must be 1, because in between 0 and 180 degree. So this one is 1/2 times 9 times 12 times 1, right? So it's 9 times 6. What is 9 times 6? 54. Okay? There are easier way to calculate this particular triangle, but this is the outline. So let's try 7, 8, 9. The same method. 31. Again, some random picture. I'm sketching here. Here's 7. Here's 8 and 9. Kayla, did you have a question? Yeah. No, we have, by looking at this circle in here and particular location of theta, that was the terminal point. You usually have something comma something, but here is 0 comma r. So for that point, sine theta we calculated like this to be 1. So that just simply in here substituted 1. Make sense? Okay. So let's do the second example, and let's see if there's still a question about what we did in 29. Yes? R can be 1. R can be anything. Still get the same answer. If R is 1, you see 1 divided by 1 is 1. Right, yeah. So because of the ratio, doesn't matter which size of the circle you looked at, those ratios are always the same. So whenever there's a convenient size of a circle that you can figure out values easily, then we're going to choose those values. Things like that. Any other question about 29? All right. So which one do you want to make this theta? My favorite choice is usually the too small a number. That's my, but you can do anything and then you will realize it's exactly the same answer. So let me put it here, theta. 7 and 8, some smaller two sides. I put it there. All right. Here's the solution. We're calculating the area in the exact way. So what is the first thing we do? Right, we're going to calculate cosine theta, and from there we're going to calculate sine theta. So cosine theta is formulated like this: 2 times 7 times 8, and 7 squared plus 8 squared minus 9 squared. This is the stage you shouldn't hit the calculator to get a decimal number. That's approximate. So this is the exact value. So you can simplify the exact value of the numerator and denominator, but never turn into a decimal. So can somebody give me the, was it 11? I think it was, or 66? What was the numerator? Right, the numerator became 32. So how does it cancel? There's a 2 times 7 times 8. Isn't that like a 4 here, right? Then it's 2. There's a slightly different, oh, because we looked at a different angle, that's why. All right, so what do you get? Cosine theta is what? Is a 2 over 7. This is called the exact value. If you turn this one decimal, you will have like 7 repeating digits, and that's not quite accurate, right? So this is the exact value. But to calculate the area of this one, what do we need? Sine theta. So the question is that, can we find the exact value of sine theta by looking at cosine theta value there, right? Where do we go? Circle. Go to the circle and sketch the certain size of a circle. So who can tell me what size of circle should I sketch in here? R equals what? 7. Right. X divided by R, right? That's how we're looking at it. 7. So x coordinate is a 2, and we know it's in between 0 and 180 degrees, so it's definitely here. That's the angle. Agree? So that's the angle theta we are talking about. We don't know what that is exactly, but there is this point. So what is the point up there? We know at least one coordinate easy. X coordinate, right? What is x coordinate? 2, and y coordinate is somewhere figure out. With that y coordinate we can calculate sine. So how do you calculate y? Is a 2 squared plus y squared equals 7 squared, right? Yes. Any other question? So let's calculate y. The y squared is what? Is it 47? 45? Is that right? Y is positive. We know it's up there. Positive root 45. Correct? There is a square factor 9 in there. We can pull it out, but I don't require that. We have a sign. You can still use this one, so I'll just keep it this way. Root 45, right? So what's the next step? Right, but we want to write down something before you have the area. Sine theta, right? We haven't written down the sine theta. What is sine theta? Are you sure? Yes, you're sure. That is the correct answer. Root 45 divided by 7. That's the y coordinate there, and radius 7 there. That's the correct number. That make sense? All right. If you calculate theta approximately using your calculator, you can also verify these are, your number you see is close to the number that's just written down here. That's the gist of it, right? You calculate cosine using the law of cosine, using the circle method, calculate the exact value of sine. So, final part, area A is 1/2 times, what times what? 7 times 8 times sine theta, which is root 45 divided by 7, right? So 7 cancels, and 2 and 8 cancel to 4. So 4 times root 45 is the area of this triangle that I sketched in here, and this theta is actually acute angle. Okay. Any other question? So I have an exercise. This time I'm hiding everything, and see if you can do everything all by yourself. Here's a 3, 4, 6 triangle. 3, 4, 6 triangle. Here's whatever theta you choose. Calculate the area. All right. So let's compute the exact value of the area of this triangle. That's your exercise. Right, I got the y-coordinate to be root 455. Just keep it that way. Then sine theta is root 455 divided by the radius 24. Is that right?